Microwaves. We all know them. We all have mixed feelings about them. They heat up whatever you put inside using voodoo magic, and some people aren't okay with that. But me? I want some of that magic for myself. So I picked up this used microwave on the cheap to harvest those organs for later. But before I take it apart, there are some projects I could use it for. A little while ago, Steve Mould mentioned that you can melt glass in a microwave. And shortly after that, Ben of Applied Science made a video about recreational glass making. And it got me thinking, what if we took Steve's idea and Ben's idea and put them together? Could an amateur like you or me experiment with glass on a very modest budget? Apparently, entry-level glass is made from silicon dioxide, sodium carbonate, and boric acid. Silicon dioxide, aka quartz, aka amethyst, aka citrine, aka tiger eye, aka chalcedony, aka Herkimer diamond, aka agate, aka chert, aka onyx, aka jasper, aka aventurine, aka sand, is a super common naturally occurring mineral. You can basically find it everywhere. I found mine in a stream bed. Sodium carbonate is added to the glass to make it easier to melt and easier to work with. I don't have any sodium carbonate on hand, but I do have something else. Sodium bicarbonate. It's not exactly the same thing, but when you heat it, it'll break down into sodium carbonate, and at the temperatures that glass melts at, it's going to break down anyway. Lastly, we need boric acid. Boric acid, like the baking soda, will decompose into something else when heated. In this case, boron trioxide. Adding boron trioxide will make the glass less likely to crack when heated or cooled. Thankfully, I know of an easy source of boric acid. Roach killer. Advertised as 99% boric acid. And the only reason I know that this roach killer has boric acid is because it also does this. So before I get started, I need to fact check something real quick. I want to make sure my microwave can even melt glass in the first place. So I'm going to do what Steve Mould did. Safety first. Oh my. I don't think I did that well enough. I guess I'm gonna have to try that again. I tried a couple more times and eventually got it to work. Oh, there we go. Alright, so a couple of notes. The microwave gets very, very hot. Much hotter than a microwave should. And that definitely can't be good for it. I don't really know what I'm going to do about that. I could try drilling some vent holes in the top, hopefully to let the hot air out. Maybe I'll try that. I changed my mind. I'm just going to go for it. I've got these ceramic bowls. Hopefully they'll be able to handle the heat. So based on what Ben was saying, we need a 1:1:1 by mass ratio of silicon dioxide, sodium carbonate, and boric acid. But I only cook by volume. So after a brief Wikipedia search, I figured out that by volume it's about 2 parts boric acid, 1.5 parts sodium bicarbonate, and 1 part silicon dioxide. Oh my. You know, I should just put it in the bag and shake it up. What am I doing? Ain't that delicious. Now, I don't think I'm going to be able to heat this up too that melting point just as a powder, so I'm going to have to use a piece of seed glass that I'm going to get from that jar I used earlier. It turns out this wasn't necessary, and I could actually just heat the powder directly. I don't think we got it. Ooh. It's doing something. I may have to move this to a more ventilated area. Alright. So I did try moving outside, but there was just too much glare on the window, and it didn't want to melt and was just generally a mess. And then the microwave overheated, so I gave up. Back inside, I took the metal case off to maybe diagnose what was wrong, only to realize I had very little idea what I was looking at. So I moved on. I eventually got it to heat up again, but it wasn't all liquefying the way I wanted it to. Oh, the bottom of the bowl is heating up now. I think I'll stop it here. I think the poor heating was due to the fact that the mixture puffed up like a sponge or a cake, or some kind of sponge cake. So I broke some of it out of this bowl and put it into a new one. Hopefully now that it's a powder again, it'll melt together. But the only thing I succeeded in creating was a portal to hell. I think the problem now is that I'm losing too much heat to the surroundings. So I took one of my fire bricks and dug a small cavity in it to serve as an insulated crucible. I filled it up and tried again. After it heated up a bit, I put another fire brick on top to try and keep in as much heat as possible. And this was definitely the hottest I had been able to get it so far. So I added more of the glass mixture. I kept heating and adding, but no matter how much I added, the crucible stayed empty. And it had also begun heating through the bottom. I had a theory that maybe the glass was eating the fire brick. To test it, I put some glass mixture on a flat surface of one of the fire bricks and tried to melt it there. After fighting with it for maybe an hour, I got desperate and put the other fire brick on top, which finally got it to melt. I tried to continue heating it, but it cooled down instead. It looked a little like the glass was eating the fire brick, but to be sure, I tried again with some glass from the jar. From this, it was very clear that the glass was destroying the fire brick. So I got some of these little ceramic dishes. Hopefully they won't melt like the fire bricks did. To start, I wanted to make sure that these were resistant to glass attack, so I melted a bunch of jar shards in one of them. I was able to melt it, but it never got hot enough to pour. So I got out another one of my fire bricks. I cut a small slab off of it to serve as a lid, and then carved out a pocket to hold the crucible. I also thought that maybe the sand I had used was causing issues, so I got out some quartz crystals and crushed them into a powder to use instead. I again mixed up some glass mixture, but this time with the newly crushed quartz, and began heating it. Once it got warm, I put the lid on it to retain as much heat as possible. After about a minute, I took the lid back off to see how things were going, and they were going very well. So I added more glass mixture and heated it again. Once I felt it was hot enough, I took it out and poured it onto a scrap piece of steel I had lying around. It was actually a bit more loose than I was expecting. Whenever I see glass being poured, it always looks more like taffy than water. I was also surprised by the light blue color. As far as I knew, both baking soda and boric acid were white, and the quartz I crushed was also an opaque white. But it is pretty. As the glass was cooling, it cracked a bunch. I took a look at the lid and found that it was being melted. At first I thought the glass was just getting so hot that it was melting the brick, but looking back, I think that somehow the glass got on the lid and began dissolving it, like before. As the crucible cooled, it was making this cute little tinkling sound. Results aren't results unless they're repeatable, so I ran it again. But this time, a hot spot appeared on the outside of the fire brick, which was a little concerning. Instead of a piece of metal, I used the back of a graphite mold so that the glass wouldn't crack as it cooled. Now that everything was settled, I took a look at the fire brick and found that some glass had gotten out of the crucible and melted a huge hole in the brick. Unfortunately, even on the graphite, the glass still cracked. To be absolutely sure I was actually making real glass, I did one more run, but this time I added significantly more quartz. Also, to test the temperature, I threw in the steel safety screws from the microwave. If they melt, then I'll know it's getting at least hot enough to melt steel. I let it cook for 5 minutes straight to try and get it as hot as possible, and... Oh my lord. I gave it a stir and set it for another 5 minutes. Right at the end, it started burning through the brick again, this time on the bottom. The glass was much thicker and didn't want to pour. I tried scraping it out with a tool, and it almost worked, but it solidified before I could separate it. As well as being much thicker, the glass was also a dark green color instead of the light blue from before. I think this was because the glass was dissolving the steel screws. So, this is what I'm left with. This one, I was just showing that you could actually melt glass in the microwave. This one, I actually tried making glass from the 3 things I mentioned before, and it actually resulted in this bead, which broke as I was handling it, but it's a nice blue color. And then, just so the first one wasn't a fluke, I tried again and made more, and made some bigger pieces. Well, a bigger piece and some smaller pieces. If you look closely, you might be able to see that there are little specks of the quartz still in there. And I was concerned that maybe the quartz wasn't dissolving with the other things, so I made these 2 with just the baking soda and the roach killer, and they looked almost exactly the same, but having left them out overnight, they got sticky and wet, which is kind of gross. Whereas the actual glass ones with the quartz in it did not, and it broke. But what are you gonna do? And this last one, I tried a recipe with much more quartz in it, and it did not melt as well, anywhere near as well as the other ones. I also threw in the 2 safety screws that were on the microwave, because I'm not putting those things back on. And it actually kind of ate away some of it. I was trying to see if it could actually melt them, to kind of gauge what temperature it was getting in there. And I don't think it melted it, but it definitely ate away at the screw. And it also made it this very dark green color, which is interesting because normally it was blue, even though I started with all white things and white quartz. So, you definitely can make glass in the microwave. I'm not sure it's the best method. One of the biggest problems I was having was that my insulating fire bricks started melting as well, which to me I thought it was getting really hot, but maybe it was just glass dissolving them, because in the last one, everywhere that the crucible was in contact with the brick, it was fine. But oftentimes, glass would make its way to the bottom of the dish, and it looks like what happened is some of the glass melted and touched the brick, and then just started melting all the way through. So, I don't really know of any materials that could possibly withstand the heat and microwaves better. So I'm just gonna have to say this is the best I can do for now. If you enjoyed and want to see more projects like this, then consider subscribing.